Good morning, student. Today we will discuss in lecture 2 of unit 2 of solution, solubility and the various factors affecting the solubility. Now, what is the definition of solubility? The definition of solubility means maximum amount of substance that can be dissolved in a specified amount of solvent at the specified temperature. This is the definition of solubility. Now, various factors affecting the solubility. The first one is nature of solute and solvent. Second one is temperature and third one is pressure. Now we will discuss solubility of solid substance and gaseous substance in a liquid solvent. The first topic is solubility of solid in a liquid. That means solute is in solid form and solvent it is in liquid form. Now first factor is nature. When we are discussing the nature of solute and solvent, we know very well all solid substances do not dissolve in liquid solvent. That means in particular solvent. Some substance dissolve in particular solvent, some substance dissolve in another solvent. That means it depends upon nature. That means here we should remember one statement: like dissolve like. This statement, like dissolves like. That means polar substances are soluble in polar solvent, non-polar substances are soluble in non-polar solvent. That means polar dissolve in polar and non-polar dissolve in non-polar. Remember, that means nature of the solute and solvent are matched. That means they are having strong intermolecular attractive force. Then solute will be dissolved in solvent, liquid solvent. Now second factor is we are discussing temperature. So in case of solid when dissolved in liquid solvent, that means solute which is in solid form when dissolved in solvent, okay, which is in liquid form. When we are dissolving solute in liquid solvent, solute will dissolve. Again, solute will be dissolved. That means this process is known as dissolution process, and solution is obtained. This solution is obtained in liquid form. Now, after some time, solute will not dissolve in a specific amount of solvent at particular temperature. At that time, solution is known as a saturated solution. Saturated solution. Saturated solution means in a given solution at particular temperature, no more solute can be dissolved. Now, when solute dissolves in liquid solvent, solution is formed, dissolution process is there. Again, here reverse process is there, which is known as crystallization. And that means from solution, particles of solute and solvent are separated. That means when a saturated solution is formed, there will be equilibrium is established. Equilibrium is established between the solute and the solution. That means no more solute can be dissolved in it. Now, effect of temperature. That means when solute is dissolved in solvent, solution is formed. There is a two possibility. Whether this reaction is exothermic or endothermic. that means based on delta H. That means delta H is negative, then the reaction is exothermic. That means heat will be evolved. In this case, as per Le Chatelier principle, if we are increasing the temperature, that means system will try to decrease the temperature. That means process is exothermic. That means when we are increasing temperature, system will try to decrease the temperature. That means reverse reaction take place. That means reverse reaction take place. That means temperature increases. We can say solubility decreases. Now suppose in this process delta H is positive. That means endothermic reaction is there. Then we are increasing temperature. Then as per Le Chatelier principle, system will try to decrease the temperature. That means forward process take place. That means dissolution process take place, and after some time new equilibrium will be established. That means temperature increases, solubility also increases. That means finally conclusion, when solid solute dissolve in liquid solvent, delta is negative, process is exothermic, temperature increases, solubility decreases, and suppose the process is endothermic, temperature increases, solubility also increases. Now third factor. Third factor is pressure. So we know very well here solvent is in solid liquid form, solute is in solid form, and the pressure having maximum effect on gaseous state. So here we have two states, solid and liquid. That means pressure having negligible effect. That means in this situation, when we are increasing or decreasing pressure, there is a negligible effect. That means negligible effect. Now we are discussing second case, solubility of gas in a liquid solvent. That means second case, solubility of gas in liquid solvent. Solubility gas in a liquid solvent. Now we are discussing effect of temperature. That means first temperature. Temperature effect. So when gas dissolves in liquid solvent, that means gas and solvent, that means solvent. We can say here solute in gas form, solvent in liquid form, and solution is obtained, which is also in liquid form. Now when gaseous solute dissolve in liquid solvent, with respect to heat, that means change in enthalpy. Always here delta H is negative. Delta H is negative. Delta H is negative, that means process is exothermic. That means same logic is applied here, same principle as per Le Chatelier. Delta H is negative, that means temperature increases, solubility decreases. Temperature increases, solubility decreases. When solute is in gaseous form and solvent is in liquid form. Now effect of pressure. So simple logic is here. When solute is in gaseous form and solvent in liquid form, we know very well gas having gaseous state, pressure having maximum effect. That means when we are increasing the pressure of gas and the gas which are dissolving in liquid solvent, so obviously gas will be compressed and the numbers of molecules of gas that are entering in the liquid solvent increases. That means more numbers of molecules of gas will enter into liquid solvent. That means we can say simple logic, by increasing the pressure, more amount of gas will be dissolved in liquid solvent. That means pressure increases, solubility also increases. Now, here one law is there, Henry's law, which describes the quantitative relationship between the pressure of gas and its solubility. So now we are discussing Henry's law. So Henry's law is simple, based on this logic. The pressure of gas we are increasing, then solubility increases. That means the solubility of gas is directly proportional to the pressure of gas. Simple statement of Henry's law is that solubility is directly proportional to pressure of gas. That means when we are increasing the pressure of gas, then again solubility will be increases. Generally, solubility of gas is taken in mole fraction. Then we can say mole fraction of the gas which is dissolved in solution is directly proportional to the pressure of gas. If we consider solubility in mole fraction, then X, and the pressure of gas is P, then we can say X proportional to P. Okay. Now this is one of the form of Henry's law, but the widely used form of Henry's law is solubility is directly proportional to pressure. The partial pressure of the gas is directly proportional to the solubility. So widely form of the Henry's law which is used is written like this: the partial pressure of gas over the surface of solution is directly proportional to its mole fraction in solution. The widely used form of Henry's law is the partial pressure of gas over the surface of solution is directly proportional to its mole fraction in solution. That means P proportional to X. This is the widely form of Henry's law which is used. Now if we remove the proportionality constant, then we have to add the proportionality constant, that means P equal to KH into X. Here P equal to KH into X, where KH is known as Henry's law. Henry's law constant. Henry's law constant, otherwise Henry's constant. Now KH, dependency of KH and value of KH. So KH actually depends upon the nature of gas. That means KH first. It depends upon nature of gas. Nature of gas. That means different gases having different value of KH. Different gases having different value of KH at particular temperature. Second one, it depends upon temperature. It depends upon temperature. How it depends upon temperature? The result shows temperature increases. Temperature increases, then value of KH also increases. Temperature increases, then value of KH increases. Now we know when solute is in gaseous form, temperature increases, then solubility decreases. That means here solubility decreases. That means at particular temperature we have 4 gases. That means the gases having higher the value of pH having lower solubility, and the gases having least value of pH having highest solubility. Now third, what will be the unit of pH? The mole fraction having no unit. Generally we are using the pressure in bar. That means pH having the unit of pressure of unit, and if we are using the pressure in bar unit, then pH having unit bar. Otherwise unit of pressure, Pascal, kilopascal, whatever may be. Now how to calculate the value of pH? So simple. This is equation in y equal to mx form. That means when we are plotting the graph of partial pressure of gas, suppose in bar unit, versus mole fraction. Okay. So this equation having the form y equal to mx. That means graph will be like this. Graph will be obtained as a straight line passing through origin. This will be the graph of partial pressure of gas versus its solubility in solution. And slope of graph. Slope indicates the value of KH. From that we can calculate the value of KH. Now what are the application? Application of Henry's law. Application. So simple cases are there. Pressure increases, solubility increases, and temperature increases, solubility decreases. Remember this. That means first application is in case of soft drink, to increase the solubility of CO2 gas, we have to pressurize high. That means under the high pressure, CO2 gas is dissolved in a soft drink and then it is sealed to increase the solubility of CO2. That means in case of making soft drink, to increase the solubility of CO2, it pressurized with high pressure. Then more amount of CO2 will be dissolved. Second case, in case of aquatic life, we consider the case of aquatic life. That means aquatic species which are more comfortable at low temperature than compared to high temperature. Reason, temperature increases, solubility decreases. That means at the high temperature, the oxygen which is dissolved in water is less. At the low temperature, That means temperature decreases, solubility increases. That means at low temperature, more amount of oxygen is dissolved in water. So aquatic life is more comfortable in water at the low temperature compared to high temperature. And the third application is scuba divers. When scuba divers enter in sea water and pressure increases, when they are entering in sea, downward pressure increases, and pressure increases, solubility increases. Pressure increases, that means solubility increases. That means atmospheric gas will be dissolved in more amount. That means when they breathe, that means atmospheric gases enter in their body, nitrogen, oxygen, with oxygen, nitrogen also enter. Now when they are coming out from the sea, pressure decreases, that means solubility will be decreased. That means oxygen is used up most probably in the body for the different purposes, but the nitrogen gas are not mostly used. The solubility decreases, that means the gases which are present in blood, from that nitrogen gas will try to come out from the body, and dangerous situation will be created, and it will sometimes block the different capillaries present in the body, and this situation is known as bands. This situation is known as bands. That means to avoid this type of situation, the cylinders which are taken by the scuba divers slightly diluted with helium. That means they are using helium around 11.7%, nitrogen 56.1%, and the oxygen is around 32.2%. That means slightly diluted is the helium. Okay, this is approximate. Now fourth one, again pressure increases, solubility increases, pressure decreases, solubility decreases. That means at high altitude, that means if we are moving at the height from sea level, that means at high altitude, that means climbers, otherwise the people living which are at the high place, then what happened at the high altitude? Okay, people living at height, what happened at the height? Pressure decreases, atmospheric pressure decreases. Atmospheric pressure decreases, that means the solubility decreases. That means the oxygen, amount of oxygen which is present in air also decreases. That means breathing problem created. Amount of oxygen in air becomes less. And people which are living permanent at high altitude, then they are always facing the problem of a low concentration of oxygen in air. So obviously in blood also oxygen level is less. That means their thinking power is less. Again they are feeling weakness. That means they are not properly able to think, feels weakness, and such type of situation, the peoples we are living at permanent at high altitude is known as anoxia. So that means these are the application of Henry's law. That means simple. pressure increases, solubility of gas increases, and the pressure decreases, then the solubility of gas decreases. So I think this will be clear for you.